Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is latch design from Unit 3 Sequential Logic Circuits and Clocking Strategies. On completion, the students will be able to explain the design of multiplexer-based latches and also be able to explain how leakage is addressed in latches. Multiplexer-based latches. There are many approaches for constructing latches. One very common technique is the use of transmission gate multiplexers. Multiplexer-based latches can provide similar functionality to the SR latch but has the important added advantage that the sizing of the devices only affects the performance and is not critical to the functionality. For a negative latch, when the clock signal is low, the input 0 of the multiplexer is selected and D input is passed to the output. When the clock signal is high, the input 1 of the multiplexer that connects the output to the latch is selected. The feedback holds the output stable while the clock signal is remaining high. Similarly, in the case of a positive latch, the D input is selected when clock is high and the output is held using feedback when the clock is low. So this is a diagrammatic representation of transistor level implementation of a positive latch built using transmission gates. In the above diagram, a transistor level implementation of positive latch is being shown where when clock is high, the bottom transmission gate is on and the latch is transparent. That is, the D input is copied to the Q output. To reduce the clock load, implement a multiplexer based NMOS latch using two pass transistors. The advantage of this approach is the reduced clock load because of the presence of only two NMOS devices. When clock is high, the latch samples the D input, while a low clock signal enables the feedback loop and puts the latch in a hold mode. Low voltage static latches. The scaling of supply voltages is critical for low power operation. Unfortunately, certain latch structures don't function at reduced supply voltages. For example, without the scaling of device thresholds, NMOS only pass transistors don't scale well with supply voltage due to its inherent threshold drop. At very low power supply voltages, the input to the inverter cannot be raised above the switching threshold and thereby resulting in some incorrect evaluation. Even with the use of transmission gates, the performance degrades significantly at reduced supply voltages. Scaling to low supply voltages as a result requires the use of some reduced threshold devices. However, this also has some negative effect, that is, it is exponentially increasing the sub-threshold leakage power, and this leakage energy is insignificant when compared to the switching power. However, with the use of some conditional clocks, it is possible that resistors are idle for extended periods and the leakage energy expended by the resistors can be quite significant. Many solutions are being explored to address the issue of high leakage during idle periods. One approach for this is the use of multiple threshold devices as in the given diagram. The shaded inverters and transmission gates are implemented in low threshold devices. The low threshold inverters are gated using high threshold devices to eliminate leakage. During the normal mode of operation, the sleep devices are turned on, and when the clock is becoming low, the D input is sampled and propagated to the output, and when the clock is found to be high, the latch is kept in the hold mode. The feedback transmission gate conducts and the cross-coupled feedback is enabled. There is an extra inverter needed for storage of state when the latch is in the sleep state. During idle mode, the high threshold devices in series with the low threshold inverter are turned off. The sleep signal is high, thereby eliminating leakage. It is assumed that clock is in the high state when the latch is in the sleep state. The feedback low threshold transmission gate is turned on and the cross-coupled high threshold device maintains the state of the latch. Quiz questions on latch design. Explain the design of multiplexer based latches. Give a note on low voltage static latches. Thank you.